All right, let's talk about a piece of technology that completely flipped the script on how software is made: containers. You've probably heard the word thrown around, but what are they really, and how in the world did they become the engine behind, well, almost everything we do online? Let's dive in.
So put yourself in a developer's shoes for a second. You've just built this great new application. The thing is, you need to run it in its own little private bubble, a totally isolated world, completely walled off from everything else, so nothing breaks. How do you do that?
For a long, long time, the go-to answer was something called a virtual machine, or a VM. Super powerful, but also kind of heavy. And you know how it is in tech. Heavy and slow are just begging to be disrupted. So what if you could get that same perfect isolation, but in a package that was way, way lighter and faster? That's the question that changes everything.
Okay, so to really get why containers are such a big deal, we gotta look at the world before they existed. So let's quickly break down the old school established way of doing things, the virtual machine.
A virtual machine is pretty much what it sounds like: an entire computer simulated inside your actual computer. It pretends to be real hardware, CPU, memory, the whole shebang. And because it's a whole fake computer, you have to install a full-blown operating system on it. This whole operation is managed by a piece of software called a hypervisor. The bottom line: because you're booting up an entire OS every single time, these things are huge. We're talking gigabytes. So that's the heavyweight champ. Now, let's bring in the challenger, the one that came in and just completely rewrote the rules. So what in the world is a container, and why is it a whole new way of thinking? At its core, a container is just a single, self-contained process. It bundles up an application with all the little bits and pieces it needs to run. But here's the magic trick: it doesn't need its own operating system. Nope. Instead, it just shares the core, the kernel, of the machine it's already running on. That one little detail makes all the difference in the world. So you're probably wondering, how is that even possible? Well, it comes down to a few brilliant features that are baked right into the Linux kernel. First, you've got namespaces, which basically throw an invisibility cloak over the process. It tricks the application into thinking it has the entire machine all to itself. Then you've got control groups, or C groups, which act like a digital fence, telling the container exactly how much CPU and memory it's allowed to use. It's this one-two punch that gives you that perfect isolation without needing a whole new OS. All right, now that we've met both of our players, it's time for the main event, the head-to-head comparison. Let's put containers and VMs in the ring and see how they stack up on the things that really matter: speed, size, and just how easy they are to move around. But before we get to the nitty-gritty, let's lock in the one big idea you need to remember. Virtual machines virtualize the hardware, which forces you to install a whole new operating system. Containers, on the other hand, virtualize the operating system itself, letting them all share the host's kernel. If you remember just one thing from this whole explainer, make it that. And when you actually lay it all out, the differences are just staggering. Size: we go from gigabytes down to megabytes. Instead of a clunky hypervisor, you use a super lightweight container engine. But here's the killer feature: portability. A VM is often tied to a specific hypervisor brand, but a standardized container, it can run on pretty much any modern machine anywhere. That is a huge, huge win for flexibility. And this chart really just drives the point home. Look at that size difference. We're not talking about a small improvement here. This is a whole other level. This is exactly why you can run hundreds, even thousands of containers on a single machine that might struggle with just a handful of VMs. It was a complete game changer for efficiency. Okay, so if you're gonna work with containers, there are two words you absolutely have to know: image and instance. One is the blueprint, the other is the thing you build from the blueprint. Understanding that difference is key, so let's break it down. Here's probably the best analogy for it, especially for any programmers out there. An image is to an instance what a class is to an object. The image is the static, unchangeable blueprint, and the running container, the instance, is the live thing you actually create from it. It's really the perfect mental model. So here's how that workflow looks in practice. A developer bundles their app and everything it needs into a single read-only file called a container image. That's the master blueprint. Then a tool like Docker takes that image and uses it to launch a live running container instance. And here's where the real power kicks in. You can take that one image and use it to instantly stamp out thousands of identical, perfectly isolated copies of your app across all sorts of different machines.
So yeah, the technology is super clever, but why did it literally take over the entire software industry? Now we get to the payoff, the real-world reasons why developers absolutely love this stuff and rely on it every single day. Honestly, the benefits are just transformative. First off, by bundling all the libraries right into the container, you kill off those annoying dependency problems for good. This makes your whole workflow incredibly smooth. You can build and test something on your laptop and know with confidence that it's going to run exactly the same way in the cloud. That rock-solid reliability makes containers the perfect building block for automated systems and the number one choice for building modern apps out of tiny, independent microservices. When you boil it all down, it comes back to solving the oldest, most frustrating problem in software history, the well it works on my machine problem. By packaging the application together with its environment, containers guarantee consistency. What you build on your laptop is what you get in production. No surprises. It's the ultimate what you see is what you get for your code.
And that really brings us to the big picture today. Software just keeps getting broken down into smaller and more distributed pieces. And as that happens, the need for these small, portable, and super consistent packages is only getting bigger. So I'll leave you with this question to chew on. Are we watching containers become the new undisputed default for how all modern software gets built and run?